Okay, so thank you very much. I was asked as a short introduction, because AI is this big buzzword that we hear about all day, to give everyone who's not so familiar with the technology a little bit of an overview and a little bit of insight what it is. To all those super tech-savvy people, I apologize. This is going to be more an introduction-y course. But come see me later, and so we can nerd around in the corner about the real deep technology. So I'm looking forward to that. So as the introduction says, the Hitchhiker's Guide to Artificial Intelligence, I choose that name because I wanted to make it very lightweight in the way that we go. So come with me on a ride. And as classical as the movie was, first things first, who am I? So as the introduction says, I'm one of the founding partners at the Venture. I am the current circle lead for Backend and Data Engineering. And I'm also appointed member to the ESO Joint Technical Committee, Subcommittee 42 on the standardization of artificial intelligence. Yes, standardization is fun. So I've been thinking a lot about artificial intelligence, what is involved, and I'm happy to share a little bit about that. But first, always bring a towel. Start with a definition, right? What is artificial intelligence? And that's already the point where it gets juicy, because we don't know. This term is so widely used, it's so ubiquitously nowadays in the startup scene that it's really hard to pin it down what it actually means. And if you look into the standardization documents, you don't find a coherent standard definition. So here are my 3 tries to find something that comes at least close to a definition. So first, it's always good to look in the Encyclopedia Britannica. And there it says, the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. That's vague. But it already includes 2 things that I think are really remarkable. It includes performing a task, so we're doing something, and we're doing something in a way that we normally associate with human beings, right? So with intelligent beings or human beings, the definition varies sometimes. So that I think is great, but there is one definition I like a little better, which is artificial intelligence is that activity devoted to making machines intelligent. Okay. And intelligent is that quality that enables an entity to function appropriately and with foresight in its environment. That already gives you a little bit of a hint where it goes. It is interesting because the definition goes in a quality sense. So it is that quality that makes a system better, or a quality that makes it smarter, and that this entity has some functional appropriability in its environment. So we have some environment that the system integrates in, and some functional probability. What's interesting with this, if you think that it's maybe a little too high of a definition, given that it might be arguable if humans actually pass that with functional appropriately in its environment. There's one definition I also really like, and that touches very much what we heard with the buzzword, is the definition to say artificial intelligence is everything sapient and smart that we do not know how to build. Because the moment we know how to build it, we give it another name. So per definition, AI is the buzzword of everything we don't know yet. Because the moment we know how to build it, we start to give it a name of linear regression, deep learning algorithm, deep neural net. We give it another name that specifies it more, and the rest stays artificial intelligence, right? So that's why I like that definition also, because the buzzword is inherent in that definition. Good. So where does AI generally fit in? And I was asked to define industries that AI might touch, and I was like, yeah, I cannot name all industries, right? Because in the end, AI is a tool in your toolbox that you can use to solve a specific problem. And with all tools, you have to be very careful to not fall into the instrument bias, that you say, if I have a hammer, every problem is a nail, right? And if you only have artificial intelligence, you have to knock everything with artificial intelligence. That might not be necessary, but it might be the right solution. So consider AI as something you have in your toolbox to use for a specific situation where artificial intelligence can and is useful. So there are basically 2 basic approaches of artificial intelligence. This is quite arguable, but I think it can boil to 2 approaches. The first approach is a very rule-based approach that we find during the 1950s, 1960s where we worked a lot with knowledge graphs, semantic web, symbolic AI. This is what's the good old school artificial intelligence that we know. Still valid, still works, still has its merits. And then there's this new shiny fancy thing that we do with machine learning, where we basically have three categories that we distinguish. The first one is supervised learning, unsupervised learning, and reinforcement learning. And within supervised learning, we have this big buzzword called deep learning that I'll explain to you in a minute. So, what is the big difference? What is the big difference? Yeah, obviously don't panic. I'll explain it to you. So what's the big difference between supervised and unsupervised learning? And that's actually super primitive. Supervised learning is learning categories from labeled data. So if you have a two-dimensional coordinate system, and you have crosses and you have spheres, what you learn in the system is to differentiate with this boundary condition between the spheres and the crosses. So if a new data point comes in here, the system would learn that it's a cross, because the boundary condition tells us that everything above here is a cross and everything below here is a sphere. That's a very simple example for like a two-dimensional problem. In reality, the problems get way more complicated, but I think it's good to understand. So the system learns from those data that you give it to him, and you give him the solution and say, here's the solution from a couple of examples, now learn from it. On the other hand, unsupervised learning, I would say, is learning insights from raw data. You don't have the solution to the problem, but you give him all the circles and then say, please find the circles that are similar to each other. So it finds those clusters here, for example, and says, like, those four circles and those, they're kind of similar. I don't know what they mean, but I know they have some similarity in those coordinate systems, right? So it learns that if a circle comes here, it might actually be in this cluster. It has no understanding if this is cats, dogs, and rabbits, but it knows there's some similarity to it. And that's what it learns. So deep learning and deep neural networks are now something that goes a little bit deeper into supervised learning. What you have here is really interesting from a perspective. You have a net with some input sensors and some output sensors. And then you have those yellow neurons in the middle. And at the beginning, when you start training the neural net, all those connections are randomly instantiated with weight. Completely random. Doesn't make any sense. It's just randomly associated. And then you start training it. And you start training it by applying the question and the answer and tell the network to find a solution where if you apply this, the right things comes out. So you're training the weights in the network backwards to really give you the same distribution that you would need to have the correct answer. And you do this with a lot of data. And then something very interesting happened. Those weights, they adjust themselves. So if you put something new on the red, you suddenly get a correct blue as an outcome. It's magic. And to show that a little bit, because then it becomes clear, I made a little video. So for everyone that doesn't know, that is the TensorFlow playground. What you have here is the red inputs. Then you have the yellow neurons. And then you have kind of the outcome here. And let's start the training of the neural network. So you see, this is the trainings data here. And you start to see the loss curve, like how the training of the neural network works. You start to see that the network learns. It learns this corner quite well. It has a bit of mistakes here. But as you see, the neural network adapts quite, and yeah, there it learns it, right? So over time, the weights here adjusted correctly to have the right output in terms of the coordinate system that is needed to learn that structure. Again, very easy, very abstracted, but that's basically what happens under the hood. So last but not least, reinforcement learning, and that's the real catch. Reinforcement learning is basically learning sequential decisions or decision-making in a process or in a maze. So what it does is you have this little system here where an agent takes an action in an environment. The action is monitored by an interpreter. The interpreter says this was a good or bad action through a reward, and then gives the state to the agent. So the agent can then takes the next action. And everything that the agent does is basically to optimize this reward, maximize the reward in that function, right? So you have a really flowing system where the agent tries to maximize its rewards function. Obviously, you have to have a good reward function, because if your reward function is not good, you're optimizing the wrong way. And that's kind of the trick you have to follow through. So let's pin that down a little bit on the landscape. Let's take a look back. Where are those techniques? And I think there's a really nice crosshair to play on the artificial intelligence phase. So on the one hand of the crosshair, you have a very narrow, specific trained AI. And on the other hand, you have a very general, universally applicable artificial intelligence. And on the y-axis, you have weak or pattern-based AI and strong human-like AI. So the easy parts are quite easy to spot. Hollywood is here, right? Hollywood is general, strong, human-like AI. This is all the movies that we see. This is the futuristic, Terminator, whatever you want. And the classical symbiotic if-else decision tree is absolutely here in the corner. It's maybe even here in the corner, right? So this is basically the extremes. So where does the rest of the methods fall into? Well, supervised and unsupervised learning are still very weak. There's very pattern-based driven artificial intelligence, but they are not so narrow. They can be used in a lot of applications, in a lot of different use cases. Deep learning is a little bit more stronger, but it's still very narrow. It can only train what you give it to the network, and then based on that, execute that. And the interesting part is reinforcement learning, because it sits quite nicely there in the corner of, quite interestingly on the reward function, quite strong, but also quite interesting on the narrow margin, because it can be used for a lot of examples, as we'll tell in a minute. So as you can see, we're still very much in the left corner of artificial intelligence. We haven't touched anything machines taking over conscious beings. Tomorrow the Terminator starts. There's still a long way to go that direction. So what can I do with artificial intelligence? There's so many use cases, and I tried to break it down into a couple of use cases that might be interesting to everyone in the audience. So you can do text processing, right? You can classify text, you can write a chatbot, you can communicate with a robot, you can do sentiment analysis, trying to get the mood out of the language, out of a sentence. Is that email written angry or is it not angry? And then based on that, take some actions. We have done this, for example, in a lot of our chatbots, dialogue management systems. Whoever has followed the news, a friend of mine was debating the IBM debater. It's a machine from IBM that focuses on debating human beings and actually did incredibly well. It's actually worth watching that debate because the entire arguments in that debate was done by a machine, which is super incredible. And then, for example, talking to a robot, having some sort of a dialogue management system that conveys messages or receives calls. That's everything possible with text processing. Then there is audio processing, also very interesting. A lot of our stuff still happens over telephone lines or in Skype calls. So here you have speech-to-text, speech synthesis. We see a lot of stuff where actors are actually reincarnated by giving them a voice back and like giving them new sentences even though they have died years ago. And there also machine learning is essential because it's quite hard to map those faces in the audio stream to like individual characters. And with the fuzziness of artificial intelligence, this actually helps a lot. And we're seeing this more and more today in like those small devices that are more and more spreading in our homes and have like incredible rise of prediction models. For example, those 3 devices alone had last year a growth of 126% in the market. So people are really interested in adapting this technology into their homes. And then there's speech-to-text, text-to-speech, different ways of communicating with robots. Image processing, this is also very interesting. A lot of research has been done on that field. So there's classification. There is a cat in the picture. Then there's classification plus localization. Here is the cat in that picture. Then there's object detection. I have a cat, a dog, and a duck. And then the interesting part is instance segmentation. This is exactly the outline of the dog, of the duck, and the cats. Because if you can do that, then you can do that. Then you can look at the street and say, oh, this is a car, and it has a vector, so it moves that direction. Maybe my automated car should drive differently. Oh, there's a bicycle with a person on it. Maybe I should not crash into it. So this image processing and the segmentation really helps in making autonomous cars possible, again, all driven on machine learning and image segmentation. And then there's a field that I called automation, which is all about in today's days is bringing a process better and better into the forefront. And here you have a potpourri of really interesting stuff, from workflow automation to chat ops. If you automate stuff in your environment, predictive maintenance is a really hot topic, trying to get to machines before they have a maintenance problem. Anomaly detection, fraud detection, quality assurance throughout the process of stages, and recommender engine that we have seen already quite a lot of it. So as a final step, I want to give you something really from the bleeding edge, and I've been really happy that Google published it a couple of days ago, and that's basically this. This doesn't look like bleeding edge, but it is absolutely bleeding edge. So who of you guys know StarCraft? Okay, there's some gamers. Who? Nice. So StarCraft 2 is a game that is basically played all over the world. It's one of the massive multiplayer, really the thing played in the community. And what Blizzard did a couple of years back was open source the controls so that an artificial intelligence could start playing the game. So what you see here is a game recorded by AlphaStar, which is an artificial intelligence playing a game. What's really interesting, and you might have heard of this game called Go. Go is kindergarten compared to that. The complexity of playing StarCraft 2 is about 100,000 times more complex than playing Go. So they trained an AI to play an instant game, and what you see here is basically what I explained before, reinforcement learning. You have an observer that observes something, then you have the agent. It's 3 neural nets that will move in a second. Then it will identify what to build, and what's really interesting, it gives you a predicted outcome whether or not it will win or lose the match. So everything that you see here is a complete player emulated by an artificial intelligence playing an online live game against a programmer, and it actually won the game against the programmer. Not just one game, but 10 to 1. And what's really interesting is that they interviewed the programmer after it, and they said the computer did moves he didn't have ever seen another human being. So the machine invented moves in that game that were unknown to humans before, and that's not just a game played by a couple of people, but by thousands of people all over the world. So that's really impressive. I encourage everyone to watch the game, even though you don't understand StarCraft. It's really impressive to see and learn. So I want to finish this lightning talk with 3 big myths that we see in our daily work and that I think are really good takeaways for everyone here in this room. So the first big myth that we always encounter is you can't buy AI. There's a lot of people coming and saying, where can I buy AI? And I normally respond to, you can't buy AI. You can buy the AI system, and you can then train it for whatever data you have and for whatever use case you have. But buying the whole thing is just not possible. You need to invest training. That's very unusual for us because we use that a program comes out of a box and works perfectly, and now we have to train the system. So that's a rethinking in how computer system works. The second big myth is AI can't learn on its own. Small asterisk. If it has a reward function, that's very specific. But generally speaking, if you repeat something 20 times to a chatbot, doesn't make him learn because it needs the trainings data, it needs the curation to bring it back into the normal learning cycle that needs to be started. And the third big myth is AI is like human intelligence. Human intelligence is so complex, and we haven't understood it fully yet our own, so we cannot design a system that is similar to ourselves. So the best we can do for now is mimic certain parts of our own brain and our own intelligence and create very weak and very narrow pattern artificial intelligence specific to a use case, and only that use case. So takeaway leaving thoughts. AI might be limited as of today, but it's already very powerful. We see a lot of things happening with a very primitive technology in artificial intelligence, and we're just starting. This is not just something that is full potential already, but this is something that we're getting more and more of. AI is custom built and trained, so there's a lot of advantage in niche products being currently developed because Google can't build everything. But if you have a niche and you can really get the data and really nail the process, you can build something incredible with a very small team. And that's probably the most, there has been some hype about artificial intelligence in the last history and in the last decades. Now we have reached a quality that makes it productable, that we can use it in production and we can put products out there that have the quality we need to run it efficiently in an environment. That's the first time we have that in that quality. So therefore, I'm super excited to hear now the startup pitches and leaving you with the classic quote from the movie again. So long and thanks for all the fish.